you need to know exactly how, when, and under what circumstances your cable's going to fail. Hi everyone, Craig Simons here from Sava Industries. Today I'm joined by Connor Chiuchiolo of our engineering department. Hi Connor.
Craig, great to be on.
Nice to have you. I want to talk about lifecycle testing today, but before I get to that, I want to talk a little bit about you. So tell me a little bit about your background.
Yeah, I was hired by Sava Industries about 5 years ago. I started as an intern and I worked here through my university work for about 3 years. And then when I graduated, I was lucky enough to be offered a full-time position. So I've been working here ever since for the last 2 years.
Fantastic. So let me dive in. Life cycle testing. What is life cycle testing?
Life cycle testing is a broad, overarching series of tests that can be used to gain a metric on how a cable will survive in a certain scenario. And this metric is then used to make conjectures and inferences about different cable material types and geometries, stuff like that.
Make a decision on the cable.
Exactly.
Right?
Yep.
Right? Okay. So why is this so important?
It's important for many reasons. You have to be sure that your cable is going to be able to survive its real-life resting place. That being said, it may only need to survive several cycles. It's single use case, maybe even. It might have to survive several thousand cycles. What we're trying to prove here is that the cable can survive well past what it's intended to be used for.
Okay, so if I'm using cable in a surgical robot, I only need that cable to move 5 times during a surgery.
Yeah, sure.
And that's it. After that, the cable gets removed, it gets discarded, replaced, and we start it all over again. I don't expect the cable's going to fail after moving 5 times. So why would I need to perform a life cycle test if really that's all it's ever going to do?
Yeah, I think you might be right here. You're on the right track. It might not fail in the traditional sense of just breaking.
Okay.
But we want to make sure that this cable can be as pristine when it went in as when it went out. So that being said, we need to make sure that this cable can survive cycles well into the thousands if it's going to only be used 5 times, because we want to make sure that it doesn't fray or stretch or any type of failure mode that could cause the customer to back out of a certain material choice.
So failure isn't really just the cable breaking. For someone like you, there's many different kinds of failures.
Oh,
right?
yeah. Yeah, like I said, this could be stretching past the spec of the customer. It could be fraying. It could contaminate a system. It could cause bearings or sheaves to prematurely wear. These are life or death situations that we can't be playing around with faulty cable.
So you also experiment with a lot of different materials. And a material we do a lot of work with is tungsten cables, especially with surgical robots. When you're doing a life cycle test, is tungsten cable outperforming the stainless cable? Is that just becoming the standard of what we should just use every time?
Yeah, I'd say yes and no. The tungsten that we use, we test here, and we see linear pull strengths upwards of 30% stronger to stainless steel many times. This doesn't always correlate to life cycle testing, though. That's what we're trying to prove here. The cable needs to survive in its specific system as well as keep these numbers that are in the other tests.
Okay.
So a tungsten cable is very malleable. It can bend around tight corners and pulley systems. And this is inherently good for tungsten. In medical devices, there are a lot of sharp bends, a lot of small miniature-sized pulleys that can cause shear strain on the cable itself. Also, heat's a big factor in these tests as well. You can't have a system that's going to overheat the cable to which the cable starts to melt or even stretch beyond what it's supposed to be.
Okay.
These cables, although like tungsten cable might outshine stainless in most of the testing you see around the block, but that is what cable life cycle testing is here to prove, is whether or not it's going to withstand the best in that specific scenario.
Okay. So when you perform your testing, Are you able to predict the results, or are you surprised sometimes with the way something might fail way before you thought, or it just keeps going and going?
Many times, I can walk in and pretty consistently predict how the material is going to react to certain systems. We're doing thousands and thousands of tests per sample here. And as you go along, you might be able to make inferences and conjectures about these things, but many times there are scenarios where I'm like, a material might outperform another, and I'm like, that is new information for myself. And that is what makes this so much fun, is this is kind of a realm that not a lot of people are looking at the moment. And this is why life cycle testing is so special. This is what makes this test more important than, say, your standard yield or breaking strength test.
So when a test surprises you, for one reason or another, do you walk out of it saying, hey, maybe we need to try something else? What happens after the test?
That could be the case. Many times the customer might come to us with a set of materials that they want to try out, and we are able to then tell them which might fit best in their specific system. But otherwise, the cable might perform just exactly how we thought it was going to, and this just affirms what is being tested as well. Many times the cable might meet spec pre-hand and then fail in the tests, and that's when change needs to occur. But many times a cable might survive well past what they need, both cases. So tungsten, stainless, either one might survive. And then you have to look at, say, other things, the heat capacity and its ability to bend around tight corners. That's going back to the last question.
Or you might even be in a scenario where you have a really good decision to make, both perform well, and you just have to make a choice.
Exactly.
Wow.
That cost effectiveness of the cable per foot might come into play.
Right.
Stuff like that is always important.
Interesting stuff. Well, hey, listen, Connor, thank you very much for your time today. I think this was very informative. Now, go break some more cable for us, all right?
Will do. Thanks, Craig.
All right. For more information, go to savacable.com. Leave any questions or ideas in the comments. Find us anywhere on social media. And remember, we have a full machining department and engineering staff. We can custom manufacture just about anything you like. Let us know how we can help you. Thanks.